Okay, thank you for the introduction. I'm Mathieu, I work at 30U, and I mostly do incident response, and I do detection as well in my team. So in this presentation, I will shed some light on how we have implemented Sigma at scale, and how we have practically implemented the transformation of the rules and so forth. So this presentation is TLP clear. Feel free to take picture, share. It's all clear. So in this agenda, I will obviously go through what is Sigma, how we have implemented detection as code in our workflow, and I will present our tool with Droid and the conclusion of this presentation. So let's head to what is Sigma. So Sigma is a generic rule signature format where you have a YAML file as a detection rule. It's clear, and it's a YAML file where you have your detection logic explained, and with that file you can share, and it is designed to be converted or integrated in various tools for incident response or for threat detection. Sigma is a very active community project, and a lot of backends are already out there to transform the Sigma to the most known platforms. So how does it look like? Sigma is actually a file, okay, where you have it's a YAML, it's clear, and it's generic enough so you can all understand what is the detection logic. And it encourages to share the detection rules in your communities or publicly on Sigma HQ on GitHub. And once you have the detection rule, you can convert it to your platform. And there you go, you have the Splunk SPL, for instance, from that detection rule. So Sigma was introduced in 2017 by Thomas Pascal and Florian Roth. And it was actually at the Hacklu. And back in the days, the transformation and the conversion was handled by Sigmac. And since 2023, Thomas introduced PySigma. And it's actually a Python library where you can parse the Sigma rules and convert it into queries. So PySigma introduced the concept of the backend and the pipeline. So backend, you need to see the backend as a driver to transform your Sigma rule to the destination platform. And the pipelines are the transformation that you will apply for your environment, so the rule can be converted to a search that matches your production environment. So how a pipeline looks like. So you have, it's also a YAML file that you combine with your Sigma rule, and you state some transformation along the way before it reaches the finite stage. So in this example, I'm adding for Splunk some index condition to the rule, and you can add some rule condition where this transformation will be applied only for the log sources, the process access, and for Windows, for instance. In addition to that, you can apply some post-processing and standardize the output of your query, which is highly useful for the automation. Well, Sigma, deploying Sigma is not easy. While it works out of the box, so you go on Sigma HQ, you take the rule, and then you have your rule. It doesn't fit your production environment. You have other fields. You have endpoint logs that are mostly not standard. We fields that are not standardized. And while the concept of Sigma is really nice, it's often criticized where people say, okay, Sigma is nice, but I cannot put it on my SIEM because my SIEM has a lot of the sources. The logs has a lot of constraint where the Sigma rule, the converted Sigma rule, doesn't fit and doesn't match the logs. So, but things have changed thanks to PySigma, and it's now possible to deploy Sigma for a threat detection service. But before I jump to our implementation, I need to tell you about our context and how we ended up running Sigma that much. So at 30U, we serve 90 plus union entities. So it's the institutions, bodies, offices, and agencies. We are the third for the institutions. And for some of them, we do security log monitoring. And as you can imagine, we are sort of MSSP dealing with cloud and on-premise environments. So we deal with multiple SIEM and EDR, and handling the detection rules manually for many instances is a no-go for us. So we decided to embrace Sigma, to have a vendor-agnostic entry point, and with some engineering to convert it for the destination platforms. So we embraced the detection as code. We have a Git repository in our environment where by using a Git repository, we obviously unlocked the possibility to have content versioning. With that, we are much more modular, where in our toolchain we can integrate more modules and checks, and we could implement some quality assurance testing. Sigma is mostly a vendor agnostic entry point, and throughout our incidents and threat hunting engagements, we add more Sigma rules to our repo. And with that, we transform the rules through a CI/CD pipeline, and we deploy it to the destination platforms. Having detection as code has many benefits among my team. So it has improved our collaboration, where when I'm adding a rule, it is checked by and criticized by other people from the team. And it is documented, and everybody knows what I'm changing to the rules and what I'm adding to the threat detection content. Despite having a good quality assurance process that is automated, we still introduce 4 eyes policy to reduce false positives. And that significantly reduces the alert fatigue on our end. And all that is ensure a continuous and iterative process. So I can add another rule, and we have the same process. It will be checked and so on. So to achieve that, we have introduced Droid in our environment. It stands for Detection Rules Optimization Integration Deployment. And it's basically a PySigma wrapper, so it will mainly use PySigma. And the whole goal of Droid is to deploy so the detection rules from Sigma to the platforms in an automated way. So it has the capabilities to validate, convert the rules, search in our logs, and report for findings. We get to that later. Export the Sigma rules to the platforms, obviously. And once it's deployed, we check the integrity of the rules after that, and continuously. Since the launch of Droid, we have now 4 platforms. We have open source Droid, and we already had some contribution, and we have added 2 platforms to the project. While we support Sigma, we still support the raw search for the destination platform for many reasons. If Sigma has some limitation, we still have the ability to have the raw search query. So once you install Droid, it basically use your Git repository. So it needs a terminal configuration where you state the basic config file, where are the raw rules, where are your filters, and the validation configuration. It's highly flexible, and if you version that, it will appear on your Git logs. And the conversion logic is by platform and log sources. in this tunnel, you have the configuration that is stated in the platforms. So how does it work? When I introduce a detection rule along the way, it is validated as per the Sigma syntax. I convert the rule thanks to Droid, and we search the rule in our datasets. And we are working on testing the detection rules thanks to the Atomic Red Team framework. And we export the rules in the end. So all of that is backed by the CI/CD. And if I fail at the validation, where the Sigma syntax, I go back. Same for the search. If we spot some false positives, we go back and we apply the right filters. So now we go through all the features. So in the validation process, we use the PySigma validators. So Sigma has native validators, where a validator checks if your Sigma rule respects the specification, and it will also check your detection logic. So if there is so PySigma is able to spot if there will be an error in the conversion process. It's obviously configurable, so you can apply some exclusion for the validation based on the syntax, and it will flag and it will put an exit code if there is an error. Now we'll head to the most important part, which is the conversion. So based on the Sigma rule, we will mainly focus on the log source. So in Sigma, you have the log source metadata, and we check the combination of that log source. So in this example, you have process creation and Windows. And with that configuration, Troy will match in its configuration if there is a match, okay? And if we have a match with Windows and process creation, we will apply some pipelines, the right pipelines for that process creation for Splunk, for instance. And we do that for all the platforms. So we engineer how the data should look like in the output of the Sigma rule per platform and per log sources. With that, we engineer once for the process creation for Splunk, and if anybody in the team wants to contribute and add more process creation, he doesn't need to tweak or go back into the conversion process manually. It's already done. Droid will just convert the rule for that log sources, and that for all the platforms. Now, for the conversion, on the top left-hand side, you have a rough idea of how our Git repo looks like. So we have a folder, pipelines, and the rules. When Droid will process a rule, it will load, it will do the match that I showed you earlier. It will load that and it will apply the right pipeline. For this example, the process access. And for process access, I want the right output fields, okay? And I want to aim at the right index, and that is made thanks to the pipeline. And it's very important for us to standardize the output, so our automation toolchain expects the right fields and so on. Now, Sigma introduced a really cool feature, which is the filters. So for some of the rules, you can have a good detection rule, but in your environment, you could have a weird, let's say, a weird behavior for PowerShell, for instance. And you have checked that, and you say, okay, it's a normal activity, but we need to filter this out. The rule is good, but we need to filter this out. So you have two possibilities. You can you can put in your Sigma rule the exclusions, or you can document your exclusion by adding some filters, and these filters will be applied to the right detection rules. So you can have multiple filters to multiple rules. In this example, I'm excluding some administrator. Okay, so if it starts by ADM underscore, it will apply the not user ADM wildcard to the rule. That allows us to document and explain why we have excluded that for this specific Sigma rule. And with Druid, you just have to state the filters folder, and it will just apply the folders, and you have to just rerun the command, and it will apply the filters. Now, after the conversion process, we check in our logs to uncover potential false positives. So sometimes you can get surprised, and you have a blast of results, and you check those results, and you say, okay, my detection logic is wrong. I need to go back and check that. Or you have good detection logic, and you have to apply more filters. And we count on our analysts to do that check, but we still do the checking in the CI/CD pipeline. And if there is a match, it will tell you, okay, I have a match, and check the results. As I said earlier, we are dealing with the cloud environments, and in the cloud you have some tenancy concept and workspaces. So in Microsoft Sentinel you have workspaces, and XDR you have tenants. We have introduced something we call the MSSP feature, where when you search the rule or you export the rule, it will interact with the right tenants. That requires some settings and some permissions, but this is really good for us because we can hit on the data sets and look for any false positives at the early stage. Now we are working to introduce some unit testing in this along the way. So we want Joey to use Mike Caldera and some Atomic Red team to test the rule. The idea is to execute a test in a lab, and a Sigma rule is linked to a Mike Caldera ability ID, and then the automation will just execute remotely that behavior. And the idea is to execute that and check in the data sets if it has detected the behavior. We are doing this manually, but we hope to make this a feature available by the end of the year of next year. In the deployment, we want the rules to have the same setting. Okay, we have introduced a global configuration. On the screen, you have a configuration for Splunk, and still it's in the Druid configuration. So we state which fields should be suppressed and so on, and all the rules will have the same settings when we export the rules. It gives us a lot of flexibility, and if you change something, we run Druid again, and it will update all the rules along the way. So we don't have to go back and tweak the rule manually. So for some reason you want the settings to be different per detection rules, which is normal. We are using the custom fields of the Sigma specification to implement some fields of our own. So in this example, I say, okay, this rule has to run every 5 minutes and look back on the 15 minutes. And with that, we can disable the rule, remove a rule, and overwrite actions. So on the global actions, we have some webhooks, and we can overwrite that webhook per rule if needed. So in the process, we export the rules, and once exported, we check the integrity of the rules. So we check if the detection rule on the platforms using the API matches the conversion output, and we basically say, okay, does it match what do we have in a Sigma rule on the platforms? And we do it regularly because sometimes we get some surprise in the export because of the platform's API didn't respond and so on. So we can spot easily if our detection rule wasn't exported as we expect. So in the end of the process, our rules are magically deployed on the platforms. Basically you have the title that match your Sigma rule and your the description as well, and the query that is exported. Now we head to the usage of all of that. So we adopted the Git flow branching system. At the main branch of our Git repository reflects the production environment, the development and staging environment, and we have the feature branch. So once I want to introduce a change in the rule or add a new rule, I make a feature branch, and that feature branch goes to development and all that content. Once we have finished to introduce more rules or update more rules, it eventually goes to the main branch. We have integrated some quality assurance from feature to develop and develop to main to check for any false positives or some checks for the export process. And that's improved definitely that reduced the false positives on our side with all that checks. Now, how to get started with Droid? The idea is to get familiar with the DevOps concept of using a Git repository and the branches. And obviously the Sigma concept. And if you want to get started and use Droid in your environment, we have a Git repository we called Droid init. And in Droid init, you just have a view of how it should look like in a Git repository with the pipelines, the rules, and so forth, with a Droid configuration. But not only, we have the documentation available if you want to get started with any existing repository of detection rules. And all you have to do is just pipe install Droid and get started with the configuration. Since the launch, we have already some contribution, but we still need to improve the correlation of the rules, because Sigma has introduced a new engine for the correlation of the rules. Droid needs to better handle the rules per if the log sources are different. We need to handle that better. That's still ongoing, and we want to add more platforms. If you want to have a platform on Droid, well, just contribute and make a PR. We are finalizing the testing feature for the Mike Caldera and Tommy Red team process. If you have experience to share, please reach me out. I would be definitely interested to hear about your experience. And now we head to the conclusion of this talk. So using Sigma in our environments is very essential for our usage, for the threat detection service. So we are dealing with multiple SIEM instance and multiple EDR, XDR, whatever instance. And we wanted to have a single vendor agnostic entry point. So our detection logic remains, and if we need to change the SIEM or EDR, we just need to engineer how the rule conversion per log sources, and that's it. Instead of spending 1 year changing 200 detection rules for the next query language. So we build this wrapper and we share this. We share Droid to the community, and feel free to go to the repo and have a look. And we using detection as code improved definitely our way to implement more threat detection content for the engineering entities. We have improved our quality assurance process. And it is highly flexible now to introduce new rule. It's really satisfying to go to the Sigma HQ detection repo. You have a lot of detection rules out there. You take one, we put it in our repository, process creation, and then we check if it's converted nicely. And all we have to do is to just put it in develop and main, and it's already in production. We don't have this overhead of having a rule and saying, okay, will it work in our environment? No, if the log sources are already ready for the destination platform, well, it's ready. So on sigmahq.io, you will find a lot of documentation on how Sigma works and the concept. Huge shout out for the Sigma maintainers and contributors. It's a highly community project that it's running right now. You have a lot of contribution either on the PySigma or for the Sigma repo with the rules. A lot of work from Anton Schlecken and David French helped me to build this presentation. You can have a look on these resources. I will share the presentation later on. And that's it for me. If you have any question, let me know.
Thank you for your presentation. What is the average duration of a Droid pipeline in your environment on the GitLab?
The average?
Duration of a Droid pipeline?
To run?
Yeah.
Well, it depends per platform. So it runs really fast on Splunk because it reads Splunk and then it responds. But when dealing with the Microsoft Graph API, it takes a while because there is rate limiting. And sometimes it's not reliable, and you have to introduce some try and retry. So it can take 30 minutes and so on for the production.
Thank you.
You mentioned at the end some new correlation module in Sigma. Can you say a bit more about that?
So in Sigma, you can change some detection logic, and you can say, okay, during this time frame, you need to have 1 or 2 detection, and then it will trigger and group by the user, for instance, or by the workstation. The correlation with Sigma is you can use it actually to correlate network-based environment with endpoint environment. That should work, and that's what we are trying to do with Droid to handle properly the correlation process. And you will find more about it on the blog on Sigma HQ.
All right, then I have one. I saw you were listing false positives as a risk. How do you do the risk management of false positives versus false negatives? Every time you tune out a false positive by filtering, you introduce the potential for false negatives. So how do you weigh that against each other?
So we have at RTU we have the ability to filter in the input and in the output. So as I showed you earlier, we can put some filtering rules for per Sigma rule, okay? And in the output, we have the flow of alerts, and we can say, okay, this one we exclude, and we logged when it's excluded, and we review the exclusion, and we know what we have excluded and so forth. So we can go back and tweak back our filtering rules.
Sorry, I didn't hear the end of that answer. Can you repeat the last 10 seconds?
I said we have filtering in and filter out. We can filter in at Sigma rules, and when we filter out, meaning we still receive the alert. And in a stream of alerts, we can say, oh, this one we don't want, but we log this behavior, and we say, okay, this pass to the alerting system, and this goes to the data of alerts flowing.
All right, so you still keep the
Yeah.
non-firing alert as a contextualization if you need to go in and hunt or try to,
Yes.
another alert.
Exactly.
All right.
This is almost completely unrelated to your talk, but I'm curious how big your team is.
So our team, so we have one team leader and four person in our team in this incident response. Yes.
The whole, wow.
Yes, so we have actually 2 person handling the detection part and 2 person for the threat hunting part. So anyone in my team should do incident response. I mean, we're all able to do incident response and forensics, but we're also responsible for our project and managing the detection and the threat hunting.
Sounds like you're plenty busy.
Yes, yes. Oh, by the way, we hire. So thank you.
All right, that is it for Mathieu, I think. Thank you.